This is the panel for kind of big data and beyond. We're not sure exactly what constitutes beyond. We'll mostly talk about big data, but I suspect we will venture into beyond to some degree as well. So we have a great panel. You have their bios. I will mention their names when I ask them the first question. And I will ask a few questions just to sort of get things going. But as usual at this event, I hope that you will start asking them yourselves. I do not have a Twitter feed in front of me, so you actually have to use your voice. I know that'll be hard. And I think you just raise your hand and somebody brings you a microphone when that time comes. So I want to start with Michael Chewy, who is a principal at the McKinsey Global Institute. Michael and Michael, I think
first year anniversary right here on the stage.
Was I the moderator or was I on the panel?
We were both on the panel.
Okay.
Yeah. You've been promoted. I stay down here.
But Michael is the first presenter, and you can see there's a little P by his name in the agenda, so that's very significant. A couple of years ago, some of you may remember that McKinsey, specifically the McKinsey Global Institute, issued a voluminous but quite provocative document on big data, and it was very popular, justifiably, and so I suppose not surprisingly, McKinsey has done some new research in this space, and Michael is going to give us a broadcast from the future about what is in this new research that's being announced after this event. Your identities are emerging.
Hi there, I'm Michael Chewy, and I'm from the future. I'm also the guy who is the other in the big data and other, right? Tom, thanks so much for the introduction and for the invitation. I'm going to stand just for a moment here, just to talk about something which actually will be released on the web tomorrow. So you all are getting a bit of a preview here, which means that anything I say we can change between now and then, so it actually gets better. But we're going to, we've done a bunch of research, as Tom mentioned, on the impact of big data and a number of other IT-related topics. We're going to release a piece of research tomorrow on the impact of a set of disruptive technology trends, which include but span across IT, but also a number of other technologies. And we're going to bring our McKinsey Global Institute methodology and rigor in order to understand, because there are a lot of publications around, let's look at these 5 technologies, et cetera, but we wanted to take a look what the potential economic impact was, just as we did for big data. Now, I'm going to actually draw the connection to today's panel, because if you look underneath a number of these technologies, and I'll just give a sample of them. It turns out there are a delightful dozen of them. I'm not going to talk about all of them today. It turns out that big data actually underlies a lot of these technologies at some level or another. And so I think that's one thing that's quite powerful. And Tom and I were on this stage a year ago, and I think one of the things that we've seen is that impact and the adoption of big data really has spanned across a number of different industries and a number of different applications. And so I think that's instructive, even as we look at some of these other technologies. So for instance, one of the technologies that we've identified is just, anyone from Pittsburgh around here? Right? I mean, I was in Pittsburgh recently, and I'm driving down the freeway, and I'm saying, what's all this stuff on the freeways, right? It's fracking stuff, right? It's hydraulic fracturing, obtaining energy, through unconventional methods, at least what used to be unconventional methods. By the way, it's interesting, that technology is advancing. It's not like Moore's Law, but it has doubled the efficiency of well production in the past several years. In addition to that, though, one of the reasons why that matters in North America is not the only place with shale gas and light tight oil. It's because in North America, we've spent the past 50 to 70 years understanding the geography of aquifers, of basins here. That big data actually doesn't exist in many other places in the world where these types of deposits exist. So, even in something as old and simple as extracting hydrocarbons out of the ground, big data has a big role to play. Let me give another example. People are familiar with the DARPA Grand Challenge set of contests, right? And so They had one for self-driving cars in the desert. Do people remember the first one of these grand challenges? Right? They put it in the desert because they didn't want to hurt anything. How'd that go? Does anyone remember? There are lots of great videos on YouTube, right? You know, you have motorcycles, they fall over, they have these huge vehicles actually running into their own support vehicles. A complete disaster, right? Terrible. Nobody actually finished it. And now, where I live in San Francisco, all these Google self-driving cars, you've all seen that, right? Well, what's happened in between? Has computer vision gotten all that much better? A little bit, yes, right? And, you know, have our algorithms gotten better? Yes. Has Moore's Law helped? Yes. But what really has made the difference? Potentially, I mean, there are lots of other things as well. It's the amount of data, in fact, right, that has come in as part of these cars, right? It's not that if you threw that car on the moon, it wouldn't function quite as well. It's because those cars are actually picking up the data as they drive around. And so they're kind of cheating. But again, the big data behind autonomous vehicles, and by the way, autonomous vehicles, you know, that's fun and interesting. Does it have economic impact? Well, you know, there's an interesting YouTube video, you know, about, it's a piece of Google marketing fluff to a certain extent, but about 60% of the way through, you discover the person who got in that car is blind. So it can clearly change a lot in terms of, you know, human outcomes. But the other thing that's interesting is you can greatly increase fuel efficiency, right? Because anybody watch that Mythbusters where they were trying to myth bust whether or not if you tailgate behind an 18-wheeler, you save gas? What's the answer? A huge amount of gas, right? 50% of the energy you use when you're driving at freeway speeds comes because of aerodynamic drag. Well, that's not safe to do in normal freeways, right? But if you had autonomous vehicles, you could, right? So that, and increase the capacity of our roadway infrastructure, right? So again, big data can allow a whole bunch of things to happen and a tremendous potential economic incomes, which are some of the other things that we studied. And then I'll just mention two other ones. Advanced genomics, right? So how much did it cost to first sequence the human genome? 100,000? Closer to about 3 billion, 2.95 billion or so. How long did it take? 12 or 13 years. It actually was scheduled to take 15 years, but surprising for a public sector project, they actually came in early. A tremendous amount of data, right? Now, how much is it going to cost? You know, how much does it cost now? About $5,000, and it's fast. But this is driving a tremendous amount of data, right? There are EMC people in the room, right? They're storing a tremendous amount of genomic data. The potential economic impact of this is clearly huge. And then finally, you know, one of the other things that Eric Brynjolfsson talked about and has written about with Andy McAfee, you know, there was a time, right, where we said there are things that people are good at, there are things that machines are good at, and we should just make sure they do what each of them are good at, right? And what we've started to see is, you know, an increasing amount of knowledge work can be done by machines, right? And this is the race against the machine argument, that it's difficult. Why is that possible? Well, it's not just that the algorithms have gotten better, but literally the amount of data that we've been able to encode. You know, when I did artificial intelligence work, it was hard in order to, you know, do natural language understanding, right? And we tried to figure out what are the phonemes that you can, you know, develop based on the acoustical analysis, et cetera, and then try to understand the syntactic tree and get to the semantics. Whereas a number of other people have realized if we apply statistical methods and just get millions and millions of samples, we can actually change the way that this gets done and become more effective, right? So now you see Siri and Google and all these other folks. Again, this ability to do automated knowledge work, you know, maybe do what doctors do, right? We talked, there was a discussion about Watson, maybe do what customer service representatives do. That couldn't be done without the use of big data as well. So what we're starting to see is this pervasiveness of the big data trend, but it can be applied across a number of different technologies and be an enabler for a number of different applications, you know, far beyond what we would have thought of as just simple, you know, analytics or BI on steroids. So I just want to throw that out there as a set of maybe provocative thoughts and have a look at the report tomorrow. Thanks.
Thanks, Michael. I would be remiss in not promoting my own work while ostensibly praising Michael's.
Are you a professor?
So I read this McKinsey Global Institute report on big data a couple of years ago, and it said that there would be a need for 1.5 million data-savvy managers. So I thought, market opportunity here. So my new book, now available, operators are standing by for your call, called Keeping Up with the Quants. Dennis just showed me one. Apparently, they're selling it here. So don't rush out of the room now. You can go later. No. Anyway, thanks, Michael. So Keith Collins is the CTO of SAS, but I guess the CIO retired, so he's, for the moment, the CIO as well. I think he's looking for one if any of you want to move to Cary, North Carolina. He might be very interested in having this load taken off of him. But Keith, I know you guys have been into big data arguably before big data was big, and I think SAS has always seemed to have a little bit of ambivalence about that term. Can you sort of talk about how you think about it and what's the general class of activities that you, and how you talk about them?
So it's interesting that, yeah, I think we do just because it has been our lifeblood. So one of the funny things, how many of you are interested in things like MapReduce, right, the big data definitions around Hadoop? How many of you have projects going, right? What's the definition of the HDF file system? It is really wide records, right? So you can have lots of attributes, really big block sizes, fast append, so you can do lots of sequential processes. What was the SAS data set in 1968? Really wide, really big blocks, fast append. The only difference between 1968 and now is the storage is so cheap that you can afford to replicate it, so you don't back it up because you have so much of it. So yes, we've seen and been a part of this whole change in trajectory. And in fact, I'm struggling a bit, Michael, around is it big data or is it big compute? And your example of the data around the geography, they've had that data for a long time, but we can finally process it at scale. We've had the same thing. We have one of the banks we work with on loan defaults. Previously, they were aggregating that up to the account level and running a logistic regression that was taking around 20 hours on a big machine. Today, by rewriting the algorithms and using commodity clusters, we're doing that in 16 minutes. Well, okay, great, it's just faster. No, it wasn't just faster. We're not doing it at the aggregate level. We're doing it at the transaction level. The volume of data didn't change. The volume we could process changed completely. Another customer who currently has a tremendous amount of demographic and web data. Their current capability is to take 20,000 attributes and reduce that down to around 400 attributes that they actually want to model against. His goal, though, is 100,000 attributes that he wants to do variable reduction on. The shift was big compute. So I really think we are in this very, very interesting time now, and this, our opportunity to solve problems at scale completely change the business processes. If I gave you another example, is one of the large retailers saw what we were doing with changing the game in optimization. And their question wasn't, well, that's great that I can do it faster. They say, if I can do that fast, I want to optimize more of the processes together. So more of the process of the business that they couldn't have seen and optimized before, now they can. So this is what I think is so exciting about what's happening right now. And this whole blueprint of a cloud architecture that puts you in a position to have compute capacity beyond our wildest dreams. It lets us look at cars, lets us look at our healthcare. We've got a project right now at NC State where it's about understanding the performance of nanos inside your body, parasites, and how much power can they drain before they do damage. It becomes a big data problem, lots to capture. But yeah, it's just a fantastic space when we look at what analytics is going to change at giving us the statistical sampling piece.
So you heard it here today. It's no longer big data, it's big compute now. Jack Norris is the Chief Marketing Officer of MapR. He told me last night, make sure you don't call it Mapper, and I'm having such a hard time, not trying to, picture a white elephant or whatever, since you told me not to. But MapR is an enterprise big data tools company, particularly Hadoop and so on. Jack, do all of your customers resonate with that term, big data, and are they all coming to you for help with it, basically?
So I think what we're seeing is a lot of big data washing in terms of every company now has some big data play. I think my favorite quote was Safra Catz in an Oracle earnings call saying, at Oracle, we're not about big data, we're about colossal data. Yeah. So
I've already trademarked the term gargantuan data, just in case anybody was interested. So,
and Gartner's talked about big data in terms of the V's, of volume and velocity and variety. And I think it's not necessarily about the data source and about the data volume, but it is about the architecture. So I'll kind of, piggyback on your point. The Hadoop distributed file system is interesting, but it is limited. It's append only, and it's written in Java. What we focus on was how do you make that enterprise grade? How do you kind of leverage it and make it more accessible? Because what we're seeing is a paradigm shift. And the model of you have enterprise storage that is separate and you have a compute over here kind of has worked for decades. And it wasn't always so. You had mainframe with compute and data together. It was just expensive when you ran out of storage. You had to buy another mainframe. And EMC was one of the companies that popularized, well, let's separate that out and make it look like mainframe storage. And it was really Google that recognized the scale that would be required and the type of data that needed to be analyzed. And when I say Google, I think everyone just has this automatic association with the dominant player in the industry. But when they came out, they were the 19th search engine on the market. Search was done. You had Yahoo that was dominant, you had Excite, you had InfoSeek, you had AltaVista with the tech cred, and here's this funny little company with a weird interface, and I'm feeling lucky. And in 2 years, they were the dominant player. And it wasn't until they published their paper on MapReduce in 2004 that they gave a glimpse to the world that it was about this approach, this leveraging of commodity hardware and cheap compute in a parallel process that from a developer standpoint looks like a monolithic approach, but is really a way to kind of leverage and process and move compute to the data. So big data is really about this architecture. It's about a way to leverage data in new ways and really become a data-driven organization and drive competitive advantage.
I want to come back to that architecture later on, but Frank, you're from TCS, a big services firm. Have you decided that big data is a sort of a separate practice, or are you combining it with your previous, I don't know, information management, analytics, BI kinds of things? And how are your clients treating it?
That's a great question, and let me take that in two ways. One, from a client standpoint, I think big data was being treated much like social and mobile and distinct separate islands, if you will. And so not just big data in the context of a social kind of problem or mobile, but just separate and distinct, right? And mostly in the form of pilots. Within TCS, it may have started there, big data as a big market opportunity, but it has quickly moved right into the information management practice area, if you will. Because personally, I view big data as just a natural evolution of information management. Technology, as these gentlemen have just said, has evolved to the point where we can deal with much more data, and we can deal with it in real or right time, if you will. So it's really, in our view, just a piece of the information management puzzle. It's just an evolution of that.
Interesting. So Annabelle is a rare non-vendor CIO on this panel. She's the CIO of TIAA-CREF, who manages money for poor academics like me and other people for the greater good. Why are you laughing?
I hope you sell a lot of books.
Annabelle, is big data a big thing at? Can I say TIAA-CREF? Is that allowed? I don't have to.
TIAA-CREF.
I have to say TIAA-CREF. Okay. Or they'll take my money away or something from me. Is it a big thing? Is it a separate thing from all the other stuff that you guys do with data and analytics and so on?
So when we first started looking at big data, everyone started hearing about it, and it's still pretty new, right? We looked at, well, what's this big data thing? It's really the unstructured data, and everyone gravitated that way. But you're hearing from the others, we've moved on and we just look at it as data because we think it is the natural evolution of where data is going. And it's just a richer set of data. So I look at it like the telegraph. You can convey a message with the telegraph, but a phone call is a richer conversation, right? So same thing. It's just where the data is going. And I think if we consider the structured data without considering all the unstructured data in the future, you're just going to have half the story.
I guess in most organizations, most large companies that I've seen, it's the unstructured data that causes more of a problem or a management issue than the large volume data. Is that true in your organization?
I would say yes, but that's mainly because we haven't paid attention to it before.
Yeah,
right?
yeah.
So you need to pay attention to it. So now you need to identify it. Where is it? What do we do with it? How do we process it? And from our standpoint, so TIAA-CREF has been providing financial services solutions to the nonprofit sector. We have over $500 billion in assets under management. And we've been doing this for a really long time, in fact, almost 100 years for the educational system. So we actually have more data than anybody about our client base. So the big challenge here is like, wait a minute, before we start really digging into what's out there in the whole world, we need to understand what do we have. So we have our structured data that we've been paying attention to, but what about all these other things that we never thought were meaningful, but now we realize are meaningful, and now we actually have tools that can process it.
So one other question from me, and then I'll start taking some others. For each of you, if you want to, tell us about a project that you're doing internally or you are doing for a client, or I don't know, Michael, that you've researched that involves, assuming we're talking about large volumes of unstructured data, sort of tell me an application domain that you think is a really interesting one to pursue.
I can start. So we look at that across three spectrums: the opportunity, the risk, and the operational spectrum. So I want to focus on two. One is the opportunity spectrum, which is how do you leverage social data to improve upon things like customer retention, customer acquisition, campaign effectiveness, et cetera. And the challenges there are obviously the acquisition of that data, but then more importantly, how do you get from that volume of social data to insight? And so we found that you need some level of ontology or intelligent filtering riding on top of your analytics that help you get from that social volume of data to that insight. And so in the campaign effectiveness, real-time understanding how people are reacting to a campaign and giving you the ability to course correct in real time, for example. On the fraud side, we're seeing a lot of insurance fraud specifically, looking at not just social data, but emails and adjuster notes and police reports and medical documents. And again, an ontology that can look at workers' comp for fraud, if you will, and know what looks like fraud and find that very quickly. So you got the predictive side of that, but how do you now leverage unstructured data with the right ontologies to get you to that suspicious claim?
Coming back to social, I heard two people in the last 24 hours said to me, social, not worth the trouble to analyze. You would disagree.
Absolutely disagree. Okay. I mean, there's so much insight available in social channels. And again, the trick is getting to that insight, right? It's a lot of noise. So how do you get from the noise to the insight? But
I mean, even defining positive or negative is a hard thing to do.
Yeah, and sentiment analysis is obviously where the space grew up. But I'm seeing a quick movement away from just strictly to understand positive, neutral sentiment. And where's the value? How can I drive a better outcome by finding the insight in that social data? But it takes work. It takes that intelligent filtering layer that need domain experts, if you will, to help create that.
Some other examples, anybody?
Probably just to follow up on one point about the social media data, one of the things we're seeing evolve in the marketplace is people recognize that a simple standalone, just look at what's happening on the Twitter feed or Facebook feed, interesting, might see something, but until actually I can bind that to the rest of my data to actually model around the whole of the ecosystem and all the channels, it really doesn't have as much value. And I think that's sort of this is the first disappointment in the hype curve of, well, I got it, but so what? And the next phase will be the so what is when you're actually binding that social information with the rest of your information around your customer base or your problem set.
Just saying sentiment's up, no, it's down, no, it's up again, no, it's down, doesn't really add up a lot of value.
What do you do with that, right?
Yeah.
So I think that will be big. But if I switch hats real quick, one of the things that I also do is make sure that we are early adopters of everything that we provide to our customers. And one of the things that
Drinking your own champagne,
yeah.
no doubt.
That's not what that's not what my team told me when they were putting the software up. But the story is really quite simple, and it's part of this change that's going on. We've brought to market a analytic server. It's all in memory, and this is, I think, part of what I want people to help understand is I think part of this change in compute is also the ability to build clusters that have memory. Same reason HANA's doing that. Same reason you have in-memory databases and columnar databases. There's a big shift going on. So we build out this analytic server, put everything up in memory, and I come to my data team and say, we're going to put all of our internal data in here. And they're like, oh, God. Oh, we do SQL queries and database queries, so why do we need to do this? I said, no, go ahead and do it. And because their normal process is these guys would get a call for a business problem. They'd go write the SQL query. It'd go run for a while. They come back and they talk to the business and it wasn't the right set of data. And they go do it again, and then they go to lunch, and then they come back, and the day's almost gone before we actually have the set of data the business is looking for. Fast forward, put this data all in memory in an analytic server, and now they are asking answers in less than 5 seconds. It's interaction with the business. And so we started small, a couple nodes, a little bit of data. Now we have 17 different business units, all the data, all in memory all the time, completely changing the way the business is responding to the problems they see. So I think there is an amazing shift going on about how we're going to be able to run our businesses and answering questions. So that's an example of we actually had to change the mindset of our current IT guys to look at a different model before, and once they got the aha, they were all in. But boy, that change management and that persistence of we're going to go there is part of what we have to, as leaders in IT, help see those opportunities and push them through.
So Eric Brynjolfsson said this morning that if big data is really going to succeed, we have to have new ways of making decisions about it. Do the people on the business side at SAS, are they ready for that kind of 5-second response, and have they changed their decision processes to incorporate it?
It happened to us just this week. We're getting ready to come up with our next major release.
Yeah.
And part of what we do in that process is look at the outstanding defects, what are the burn rates, how well are we doing coming to closure, and before, that was not the easiest process. Now we have all that data, and the managers are doing that. They're looking at their own burn down rates. They're looking, push the button, here's your forecast. Change the time scale, see if your forecast has changed. Flip the data on its side, look at it a different way, looking at correlation heat maps. They couldn't have done that before. And so, yes, just even in our own manufacturing process of software, it's changing how our managers are working.
And if I could add, the issue of getting to a data-driven culture, I think, has a lot more to do with the people and the way they're used to operating, right? So there's a lack of trust in data on a number of levels, and so the gut instinct way of making decisions is prevalent. And so I think what we find is, from a change perspective, it's hard to get folks that are used to making decisions based on their gut feeling to trust the data and make decisions based on that data. So I think it's a very large change management issue.
I sometimes joke you either have to change the person in the seat or change the person in the seat.
Right, exactly.
So we did analysis.
Is that a big issue for you guys, Jack, as far as your ability to kind of sell this technology into a company?
Well, there's a spectrum of applications, and we looked, and one of the questions was, is there a killer app for Hadoop? And just looking across the adoption, it ranges from online recommendation engines to credit card fraud to fleet efficiency for waste management to facial recognition for a Japanese kiosk. I mean, it's bizarre how many applications there are.
So the answer is no. There are lots of killer apps, but no single one, huh?
But what we did see a thread is that expanding the data available for a decision, in many cases, it's an existing application. They're just starting by expanding the data set. So instead of looking at a 30-day time horizon, they're looking at, well, let's look across 7 years. And there's a data mining class at Stanford, and the professor there has...
I'm sorry, you're not allowed to mention that school on the stage.
Well, I'm a West Coast guy.
Lost his train of thought.
Go Cardinals. Somewhere. That's all we need to know.
I can tell this is the wrong place to bring that up. Anyway, a very data-driven campus. And he brought up this mantra, which is more data beats better algorithms. And one of the class assignments, this was several years ago when the Netflix contest was going on. And so his assignment for his students, the homework, it was a class project. They had to enter the Netflix contest. And a lot of them, looked at the algorithms. And one group decided they were just going to use a simple algorithm, but they were going to augment the data. So they used the IMDb database and added that to the base data that was there. Not only did they outperform the rest of the class, they were near the top of the leaderboard. And I think a huge change this new kind of technology or platform ushers in is a different approach to analytics. And the old assumption that the analytics is an exponential cost curve and you're rewarded to sample the data is really changed with Hadoop. The cost curve is linear. Just throw more data at it, and then the task comes not trying to model the future, it's find the exceptions in the data and become more data-driven. So I think that's a partial answer to your issue about the lack of data scientists. If you can simplify the problem, you can get much better results faster.
So Annabelle, let me pick on you just for a second as a CIO. Is it your job to kind of bring about that data-driven culture, that cultural transformation, along with all the other things you have to do as a CIO?
Sure, absolutely.
So how do you go about that exactly?
I think that we've been working on this for a few years and getting the sort of data mindset into the culture, and it's not just on the IT side, it's on the business side as well, because you need to have good data in your systems on your structured side. It's just a process. You just have to keep pushing at it, and I mean, today, I look at it versus a couple of years ago, we're in a whole different space where people really see the importance and the value of it, and they're seeing how it makes a difference to really be on top of your data, right? So I think it's just, you can't expect it to be a light switch, and some people you have to bring along, some people will get it right away, but I think it is an important thing, and it's an important part of being a CIO.
I promised opening up to questions. Anybody want to start us off? We have roving microphones, right? Do we? Or yeah, we're in the process of getting roving microphones.
So while he's getting that microphone, I'm going to take an exception here to just bully through the data.
Okay.
Just to help the people as you start this journey. You're absolutely right. For the adverse events, the exceptions, one of the grand things is to be able to go through all the data. What's also true, though, is when you're looking for normal populations and segments, sampling is still a very valid technique. And one of the ways we can help is making sure that people know when it's appropriate to do sampling, because you really can't get a better answer. And that frees up resource, time, capability to look for the exceptions and the adverse events. So I think,
and there is a spectrum, right? But I think that people tend to focus on the far end of the spectrum and say, I have to dive into machine learning with Mahout and do all these techniques, which do produce some fantastic results, especially in the risk assessment, et cetera. But there are some real easy, low-hanging fruit on the other side.
Yeah.
So statistical inference is not going away, Keith?
No.
Oh, good. I know something about that. I don't want that knowledge to be obsolete. Sure, back there.
I'm Jack Vaughn from Search Data Management and .com, and I wanted to ask, a lot of the data, what's new is it's coming from the web. Well, yeah, it's like 20 years, but it's a big change, and there's a lot more influence of marketing data in terms of driving analytics with organizations. So either correct me if I'm wrong, or tell me what that is, what that means to your points of view here.
You mean the availability of all of new internet data and so on? What does that do to their existing processes and models and so on?
Yeah, and on top of that, marketing people getting data from the web are calling for these systems to be built, systems called big data.
We're seeing some new applications. So it's not like Hadoop's going in and displacing SaaS implementations or displacing data warehouse. But there's a lot of look at how do I leverage these new data sources? How do I leverage all this weblog information? And it's not to service an analyst, but it's part of an automated response. So we're seeing recommendation engines that are popping up, different suggestions. We're seeing ad platforms that are doing billions of matching and events a day. And it's part of this kind of constant operations process that's separate from kind of more in-depth analytic, I guess, analysis or studies.
Can I add something to that? I think that there is something very interesting about the fact that a lot of this data, particularly for marketing, is coming through the web, and a lot of really interesting innovations and powerful innovations about how do you use that data in order to market better. I think the other interesting thing is that those techniques now are moving into the rest of marketing, right? Who watches Mad Men, right? That we don't do marketing that way anymore, right? The quants are coming into marketing. But what that means is this ability to measure and actually find out, which half of your marketing spend is being wasted, because you can do that on the web. Now people are saying, well, how do I do that in out-of-home advertising? How do I do that for radio, television? How do I make sure that there's accountability and I'm paying for performance, not just on the web, but elsewhere, and also doing it in a multi-channel way? So there's this blowback in terms of the ability to market through the web. Now people are saying, well, why can't I do that through all the rest of my channels? So I think that's really changing the practice of marketing in a fundamental way.
Yeah, if I can add, I think marketing is actually one of the most disruptive functions that we can point to, and it's specifically that reason quantifiable now, whereas it has been very tough to quantify in the past, right? So a lot more marketing folks are held accountable to metrics that they haven't been accountable for in the past. And a couple points to your notion of marketing and the data. You're starting to see a lot of companies now think about, for example, social lead generation. Can I do lead gen out of social channels? Because some of those are real leads that you can, if you can identify them. That's one example. We see some customers that are looking at identifying social influencers and turning them into ambassadors, if you will, as a really good way to market. So just a number of different use cases popping up where this web source or social sources can start to feed intelligence into process.
And it's not limited to the web. We're seeing some box retailers that are considering their store giant web browsers, and they're looking at tracking the mobile phone usage and seeing which aisles do people stop in, what's their path through the store. I mean, it's just fascinating the amount of data now that's being brought to bear in places that you wouldn't expect.
We heard this morning about video analytics for recognizing what people are doing there, and from what I understand, you could actually recognize faces too, but it kind of goes beyond the creepiness factor. If you say, hello, Mr. Jones. You had a question or comment, right?
Thank you. There's been a lot of, my name is Doug Richmond. There's been a lot of talk throughout the day around data-driven decision-making, and clearly a lot of data is available, as people have talked about. How do you guys see the risk of relying, exclusively or very heavily on all of the data to be able to make all these decisions, especially when you take a look at it and think about it in the context of the financial markets crisis a few years ago, where the investment performance for a couple of months were beyond 2 standard deviations of investment performance for the last 50 years. So how do you try to mitigate the risk of all this data and sort of relying very, very heavily on it and not incorporating other kinds of analyses or other perspectives as well?
In other words, how are you keeping my retirement money safe, Annabelle? So,
well, I have not taken on the task of trying to figure out how to avoid the financial crisis that we just had, because it's a little bit past me, right?
Above your pay grade.
Oh my God. If I could figure that out, it'd be worth a lot. What we are doing, look, there's, like anything else in IT, there's 100 ways to approach any problem to get to the same objective, right? So we have an approach. There's many right ways of doing it. What we're doing is we're saying, okay, we've invested a lot on let's get our own data organized and in a good way and understand it really well. And what we've also decided to do is we feel that this is a place that is a space that is ripe for vendor products. So let's see what vendor products come out of this and try to leverage those vendor products to incorporate with our internal data, and these vendor products, have them bring in external data and help us to do the analysis part of it. And then the other big piece is to pick some problems and do a bunch of fast fail iterative type processes to see how we can learn. Because I don't think that you all of a sudden wake up one day and trust this whole new way of analyzing without understanding what's underneath it. I think it's an evolution. So if we pick smaller problems to solve, business problems, and we focus the energy, which is what we're doing, is creating these smaller pilots that let us see what it tells us. And I heard this earlier today. There's a big difference between data and information, right? So you need to understand that you're actually getting information out of your products and your analysis before you can start really trusting it large scale.
I think the key is better decision making, and it's not exclusively data driven, right? So case in point, I think we've talked today about agility, and I think the theme of this conference is the enterprise of the future. Well, in the future, I think decision making has to be pushed closer and closer to the edge where business is conducted, right? And so in real time or in right time, getting the right kinds of information to that edge interaction, and then allowing those people that sit on the edge to use their instincts and their knowledge along with better data to make better decisions, right? It's never going to be optimal, and I don't think you ever take the human part of that equation out.
Another way to put it is be data-driven and don't suck at it. I mean, it's possible to be data-driven and just not be very good at it and make mistakes, which arguably, is something we've seen.
I can see that on a T-shirt now. Be data-driven, but don't suck at it. So.
The other thing is, it's true with analytics that you can't predict the black swan event. But what you can do is make better decisions about the things that do have a normal distribution or a population, those things that free you up to make better decisions about where you need to use expertise.
Yeah, and I think rather than proving the limitation, I think it's pointing out it was a big data issue, right? The inability to understand the systemic risk, and that's an area that's really financial services is looking at. How do we get all the data in our view of the systemic rather than the individual movement of particular stocks and equities?
Irving, who just actually wrote that analytics can help sometimes with black swans, but maybe he doesn't want to mention that.
Yeah. My question actually is very related to what we've been talking about. And I think we've learned actually for quite a while that one of the best ways to get insights into very complex systems is the whole world of dynamic systems, not linear systems. And the reason is because when you have complex systems, you get side effects that you couldn't have anticipated until you start coupling things. And there's a whole world of dynamic systems that John Sterman and Jay Forrester so did. And I've been thinking more and more that one of the most interesting aspects of, let me use the term data science, of the applications of big data is begin to link together data sets that were previously siloed so you can start looking for those kinds of side effects, unanticipated consequences. And this is all very new, so I would like to hear from the panelists what they think about it.
Consistent with what you were saying, that coming out of that junior college in California.
Yeah.
It is called Leland Stanford Junior
University.
Anybody else want to comment on that?
Well, I can give you a couple examples. We are seeing across, especially in the financial area, this idea that they want to look at risk across the enterprise. So one of the interesting things that happened to us this past year was we have a company that was looking at our high-performance risk engine, and they said, that's really great, but we have 17 risk engines. We can't just hoist them all over with all our pricing functions and everything. And a couple of smart people got together with them, and they said, well, we've got this streaming engine. Can we stream these in real time to give us a view of 17 different risk systems together at one time? Wow, okay, now they can see some effects.
Did they find things they wouldn't have found otherwise?
They are beginning to be able to ask and answer things that they couldn't have seen before. We see the same thing in breakout fraud, when you're able to look at fraud that's happening across the different lines of business as a holistic view of what's happening in fraud. The risk and fraud definitely show up in big ways. You also get that in influencer networks when you're beginning to look at social together with your other channels. So you see it there. One of the things that we're trying to actually begin to research is what is this effect that you have when you start making decisions in real time in stream to model bias downstream. So all of our downstream processes now have a bias introduced in the early part of the phase, and there really isn't a lot of research in that space yet.
So if I can add, working with a couple of customers who have actually viewed the advances of big data technology as a way to actually break down data silos. So in effect, using the technology to now start to bring data together for a lot of good reasons. But one of the things that I think is critical here, I'm a big believer that the future of differentiation lies in the customer experience. And to create the right kind of customer experiences, you can't have fragmented customer data all over the enterprise. So tearing down those silos and giving that view of that customer data so that you enable the kind of experiences they expect, I think is critical.
I think it does speak to the fact there's so much headroom here, right? That I don't know of anyone who's actually combined the dynamical systems view with some of the data perspectives that we're looking at here. So there's lots of good work to be done there. Yeah.
Only Irving. So.
Well, Irving's ahead of everyone. Yeah, it's true.
Dennis.
Quick preface, several of you are here on the panel because of some of the sponsorship that we were able to get.
We're here? Why?
No,
just kidding.
Sorry I was successful. But I wanted just to say that it's a pleasure to have somebody from the future here. Michael, thank you very much. And this process takes about 8 to 10 months to sort of set it up. I'd like for the panel to talk to me and to the group here, envision the future, and what is big data going to be a passe fad next year? I'd like some ideas of why we should invite you back next year because of the themes and the headaches and the nightmares that are keeping CIOs up today that can be solved by new big data tools and solutions going forward. So take a look into the future for me and tell me what theme we need for this conference for next year so that I have all you up on the panel again next year.
Be persuasive. Michael and I clearly need something to do this time of year, so we keep coming back.
Well, Michael just said here, there's a ton of headroom, right? The acceleration, I'm a big fan of Ray Kurzweil's The Singularity Engineer in this, right? This innovation happens at the edge, it's the combination of practices. So do I think this has a long run in the things that we're going to be able to do and see and experience? Yes. Do I think we're going to go through the classic disillusionment, trough of disillusionment in this? You betcha. There's so many people saying big data is the solution without thinking about the rest of the processes. I know, Annabelle, you would say that you probably face some of that in your organization as well. Is, how fast do you run before you actually start showing small incremental steps? And it's the same coaching that we do is, yes, maybe have a vision, but show incremental success if you want to stay in the game. So next year you might want to focus on what are these incremental successes, because you may be right in the middle of the trough of disillusionment around big data hype.
So I think the big data term is probably short-lived because of all this disillusionment weight. I think the economics behind it, if you can get a terabyte of data delivered for around $300, fully protected, snapshots, mirroring, versus $16,000 in a data warehouse environment, there's a lot of room for adoption. Even if you don't do any analytics, you say, well, I'm going to put it there, and I'll do the ETL processing and load it in the data warehouse. So I think it'll definitely be a topic. And I think that the efficiency of an organization in terms of their analytics is going to be analogous to supply chain. So supply chain, we looked at inventory stock, right? And inventory in the system, and the measure of efficiency was how you could constrain inventory and how fast that flowed throughout the organization, kind of a just-in-time approach. And I think the same thing is going to be true for data. So the organizations that are moving raw data and doing a lot of processing and serving a lot of different silos are going to be much less agile than a company that can organize it in one spot, do analysis there, and then selectively upload to other kind of systems and sources. So I think what we talk about will change, but it's part of this huge, huge trend that's probably the biggest paradigm shift to enterprise computing that we've seen in decades.
Since the data warehouse, probably, I would say, maybe.
I'd even say before that, because you've got, even data warehouse was a special case of you still had separate, storage and compute.
So I'm a big believer that enterprise structures as we know them will change significantly in the next 10 years. And a lot of people find that kind of heresy. But I think, for example, things like the functional model that we've known for a century could eventually change in the next decade. And when I asked one of the fundamental elements of or characteristic of the enterprise of the future that drives success, I believe analytic excellence alongside collaboration and relationship excellence are one of those key characteristics. So big data as a term might change, but its enabling capabilities will kind of run throughout the enterprise, be a core fabric of the enterprise, if you will. And one of the key things that we see in terms of maturity model for enterprises that have to go through, if you guys are familiar with the term descriptive versus prescriptive, descriptive being more viewing the past and reporting on it versus prescriptive being able to predict and actually prescribe outcomes. Most companies still are on the descriptive side of the maturity model. So I think in the next several years, you're going to see a plan in place in companies to try to make that maturity evolution through the model from descriptive to prescriptive. And big data is just an evolution of that model, if you will.
So I would agree with, I think that the big part will be dropped and we're just going to be talking about data because I really believe that this is just the evolution of data. I also think in the future we're going to look back and we're going to say we had no idea what we're talking about and no idea what we had in front of us, right? Because I think that it's too hard to predict where it's going to go. It kind of reminds me back in 1997, 1998, at that time, I was working at JP Morgan, and there was this company called Amazon.com that sold books. And I remember being in my office and someone saying, yeah, sure, I mean, you could sell books on the internet, but you would never do banking on the internet.
I'll throw, just to be provocative, I can imagine a panel that is how do we take data out of the doghouse? Because I think all those risks that we worry about, privacy and security, that those terrible things could happen in the next year where that our nightmares actually come true about some of these things. And the backlash is already starting, right? I know people are playing a big data drinking game. Whenever the Target example comes up, they have to drink, right? People are sick of that to a certain extent. But it's a great story, and so I think there is a
new beer pong.
It is, the big data beer pong. So there's a possibility that the things that we worry about all the time and we work very hard not to have happen actually do happen. And again, I think this trend will endure past those things. But it could be worse than a trough of delusionment, right? You could have real problems.
So what a downer. We heard from Andrew Lowe, another financial crisis in the next couple of years and a data crisis as well. Next question.
Speaking of the crisis, right, I mean, I see, I sort of hear quite a few positive things about the big data. But I see one alarming trend, though, I mean, very recently, that lots of companies want you to put in your vital data, right, the whole vital signs and whatnot, I mean, in order to get some break in the monthly, my monthly healthcare cost, right, premium or whatnot. So where do you draw a line? For example, I mean, 5 years from now, would they be able to collect the data to see how many restaurants I happen to visit and what type of lifestyle do I have? And insurance companies taking this data and say, well, you know what, he's not insurance worthy. I mean, where are we taking this? To me, I see this pretty alarming trend. right? I mean, if you don't put in your vital signs data into the into the healthcare enrollment system, you don't get the $1,500 break that you generally get. So where do you draw a line? I mean, is that an alarming trend? Are they invading our privacy, or how does this shape based on the Obamacare that we have?
Anybody have an idea where to draw the line, or are you seeing this issue in your customers and your organizations?
I'm sorry, I'm on the side of put the chip in right here, give them all the information they can stand about me, and only give me stuff I care about.
Right.
And and it was said earlier this morning, I think it's all about the value proposition. We will give up as much data as we get in return for value. Yep. And you definitely see it in the Gen Y group. They have a belief in the technology. They believe that the right thing is going to happen. And the concern is there such a big event that delays that for a while, or do we keep a calm path? So I'm a big believer. We saw it this morning when we talked about the power of orange. How do they say that? Orange? Orange.
Orange.
About can we show the value of public data to allay those fears and then upsell on top of that. And I think that's probably the real part that's likely to happen.
Agreed.
I agree with the value proposition point. I think there's some really interesting thinking about whether or not we should be concerned about the collection and production of data or its use, right? So a lot of the current regulatory schemes about whether or not someone should actually have data or collect it. And there are people who say, look, data exhausts data. It's hard to actually do anything without data being created. And that Dana Boyd at Microsoft is one of these people who said, maybe we should be thinking about regulating the use, because that's the thing that's creepy, when you use data in a way that we don't like, as opposed to it existing, because it's hard to get rid of it once it exists.
So I have a quick question. Topic came up earlier briefly about architecture, and since this is a CIO-oriented conference, I wonder if those of you who are either CIOs or selling to CIOs, is this a really much more complex architectural world that CIOs have to navigate? I mean, it's not just relational database anymore. It's I was out at Wells Fargo a couple of weeks ago, and they said they have 4 places to store data for analysis. There's Hadoop, there's Teradata Heavy, Teradata Light, Aster. Keith mentioned columnar, in memory, out of memory. Is it a lot more complex world now, and how long will it take for that to settle down, or will it ever?
Well, we've seen research by Gartner. It's shown up in some private research we did. The #1 pain point associated with big data was too many sources of critical information. So kind of a backlash against the data silos. And the flip side of that was how much functionality can I bring to bear on a big data platform? And for us, it's search and MapReduce and NoSQL and streaming content. They want to do a lot while the data's there, and then feed systems where they've got existing processes and applications that can benefit from that.
Yeah, and I completely disagree with Gartner's point of view on that, which is data deserves...
I'm sorry, there's a 70% likelihood that they're correct.
that data in our organizations, right, strives to be free if we're going to get value in the businesses. They need access to it. So I think we're going to see far more areas of specialization of the way data is provided to the users of the business so it can run as fast as possible. So maybe our real challenge here from an IT perspective is the governance of those processes and how data flows through your supply chain example, right? It needs to flow through the organization, and it needs to be organized for the way it's going to be consumed so that they can get maximum value. We face this challenge all the time because the IT will generally say, well, I have it. And prior to the new analytic databases, it was in my relational form. Thank you. That's all you could possibly need. Why would you need any of that demographic data for any of that? Or why do you have to turn it on its side? Or why do you have to worry about missing values? Or why do you organize it differently for predictive modeling versus forecasting versus optimization? So I'm a big believer that we better federate the data, we better govern it. That's our opportunity. But we need to let the businesses have it in the way that's going to solve their problem.
I mean, I think that if you look at data, obviously it's going to be more complicated because if you only have structured data and you're adding unstructured data, by definition, it becomes more complicated. But if you look at, if I look at all of my technology, it's already pretty complicated, right? So it's just more complication of the same, but we're already used to dealing with that. And the other thing is that there's an opportunity for actually for it to be a lot less complicated if you do things like leverage cloud. In use of it, it could be a lot more easier, right?
We're early. Architectures always get complicated early in the maturity cycle, and so it's appropriately complicated.
Yeah.
Anybody have a microphone anywhere?
I have.
Yeah. Oh, okay, great.
Pavel Milonov, I'm from Clean Harbors, and my question is about one of the biggest collector of the big data is government, and probably you dealing with government agencies, how open they are of sharing some of this data. And second part of the question is when they dealing with this, how good they are at dealing with big data, analyzing it, predicting stuff in scale of 1 to 10.
Well, scale of 1 to 10. That made it easy. Obviously, speaking of complex architectures, government can be a complex architecture. As a former government CIO, a couple of things. In terms of openness, I do think there's a tremendous interest in open data. You might have seen that in this country, there was an executive order by the president recently mandating the default stance for information, for data in the government will be open. I spent some time with Todd Park, the CTO, a couple days ago, and really driving that. Now, it's going to take a long time for that to happen, and there will be parts of the government that does not apply to, many of them with 3-letter acronyms. But there is that sort of trend. There's an open data government, open government partnership with a number of countries all around the world. One of them, which actually dropped out recently, which actually suggests that might be that there is some standard to being in there. So I think there is some real opportunity there, and that the openness will continue to increase. At least that appears to be a trend. In terms of capability, though, if you look at the parts of the economy where we have not really seen an increase in productivity, it is public sector, education, and healthcare. And so the ability to apply data in order to actually have them catch up to the rest of private industry in terms of productivity, which is becoming increasingly important as we age and the support ratios decrease, that there's just tremendous opportunity there. So, I think it's a story where a lot of data's there and the value hasn't yet been captured.
Anybody else work with government much? I know SAS does, certainly.
Yeah, one of the things I would just ask you to think about, which is being a democracy, one of the things that we often think about is that everybody needs to be treated the same. Notice I didn't say equally. If the government sector could get comfortable using all the techniques we use in the industry around customer intelligence, you would only get the information that you needed. You would only get things that were valuable to you, whether it's you should worry about these tax restrictions, these tax laws, you need to understand this healthcare plan. Why doesn't the government able to give me, because they know enough about me to give me what I want? And I think oftentimes they're struggling because we bind them with this idea that equality means treat us all the same. So there's this opportunity as we think about public policy, as we influence public policy, to help understand that there is an efficiency to be gained in the government to actually treat us as citizens uniquely to what's important to us.
And we documented a story from the German Federal Labor Agency, the people in Germany who try to get unemployed back into work. And they used big data. They have great records of their interventions and outcomes in order to create a segmentation and basically brought people back into work as fast or faster and saved about 10 billion euro, billion with a B, on an annual run rate basis. So it can be quite powerful in public sector.
Question over here?
Yeah, I'm personally a bit skeptical about the strategic use of big data analytics. I can see the benefit in operational efficiencies and more real-time processing from which data warehouses suffer from. And I'd like to give you 2 examples to the panel. If you go back towards the last 20, 25 years of the 19th century, theoretical physics was grappling with the same problem. people were using it, which had exploded on the scene, and they were trying to formulate the theories from the data, from the experimentation, until Einstein came in and he said, no, this is the wrong approach. And he actually came up with fundamental postulates from which he derived his theories, and then the data would be there to supplement that, and he proved all, people like Poincaré and people like Lorentz wrong. And a more recent example is in our own field IT, that with the data-driven approach, companies like Microsoft kept on trying to build products with aggregating user features. And on the other hand, Steve Jobs had this approach, and he said, I don't trust my users. I will come up with fundamental insights about defining my products. And we know who was right.
So is there a question in there somewhere? Or, I mean, one might argue that if you think you're as good as Steve Jobs, go ahead and ignore the data. But I think many people are not as good as he was at that. Anybody have any feelings about this comment?
Well, I also wonder, did Steve Jobs ignore the data, or did he just say that's what they're saying they want, but they don't know how to tell you what they really want? Or maybe they can't imagine it.
Sure.
There's been some good discussion about the infrastructure and the platforms for data and about analytics on top of data. I think it would be helpful for the group to have some examples of another aspect of big data and its value, which is high-velocity A/B testing as a part of business process, because I don't think we've brought out enough of those.
Anybody doing that? High velocity, low velocity?
Any kind of testing?
Any kind of testing?
I mean, I harken back to this comment about, the things that what we've been able to do on the web can inspire the rest of the business. So, table stakes for any website nowadays, any sort of web strategy is A/B testing. I think what's interesting now with the Internet of Things and sensors everywhere is that you can take that approach to, viewing your organization, viewing your customer base as a place for experimentation out into the physical world. So whether or not it's retail stores, whether or not it's quick service restaurants, the activities within a production line, you can actually take that view of testing, whether or not it's high velocity, to many, many places. And it is again changing the dialogue at management into, what experiments have you run? So that's for real.
There's Web 2.0 companies on the on the ad platform piece, on the optimization for mobile, on social media, where at its core is Hadoop kind of doing these analyses and presentations and kind of iterations. So it's not you have to get it right the first time, but based on people's click-through, especially in some of the recommendation engines, so reflective intelligence that based on people's response, then you're kind of constantly adjusting the model, which is kind of an application of a Drucker fail forward fast. So you get it wrong, but you're just going to keep iterating very, very quickly. And we're seeing the same thing in more sophisticated clustering algorithms where it's not that they pick the right model from the beginning. It's the fact that you can constantly iterate across this massive amount of data to find out what the best fit is.
Any other testing comments?
Just in general, if you look at where we're spending dollars in research around algorithms and scale, a lot of that's moving. We've solved a lot of the how do we do big data in these clusters. The next is how do we do the velocities.
That some of the early adopters of high velocity testing have also started to say it's not just about how rapidly you do it, it's whether it always results in incremental change. So I talked recently with both eBay and LinkedIn who say, A/B testing tends to lead to incremental change. This is a little bit better, so we do that. So they've tried to adjust either the process or their algorithms to say, sometimes we need to do some really dramatic change to counter that effect. I thought it was an interesting thing. We are running out of time, so maybe I'll ask you all for a verbal tweet of 140 characters or less about the big data topic and your last thoughts on it. So if you were going to go out and tweet about our panel, what would you say? Who wants to go first? I will be counting the characters.
I'll start. As I said earlier, to me, it's about the analytic excellence and how it becomes part of the fabric of the enterprise. And big data, in my mind, is just one of those.
Sorry. No, go ahead.
Man, I was 2 characters short.
I'll be short. I think it's a huge trend. We won't know exactly the magnitude of it until later on, but when we look back, I think we'll see it as a big trend.
So we will be here next year, Dennis. So,
Go ahead.
I'll go big data rocks, architecture matters, try MapR.
Spoken like a true CMO.
Verging on commercial haiku there. Yeah.
Skill up your IT for predictive analytics.
Hashtag big data, still important. Hashtag don't suck at it.
Thank you very much. Thanks to the panel for being here.